Dear students, my name is Jordan Simeonov, and I would like to present a topic called Obsolete Pesticides, Sampling and Analytical Procedures. The first stage in addressing chemical pollution in different environmental media involves sampling and analysis to understand the nature of the pollution, its extent, and potential effects. A well-thought-out sampling and analysis plan tells you what, where, when, and how to collect samples and defines procedures for analyzing the samples once they have been collected. The environmental properties of some obsolete pesticides, because this information helps to understand pollutant movement in the environment and the types of environmental media that should be sampled, are presented in table and discussed. The different approaches of sampling procedures, together with graphic images, preliminary search sampling, judgmental sampling, systematic sampling, random sampling, and stratified sampling are presented. The analytical procedures, methods, and techniques in order to perform precision chemical analysis of the samples are briefly discussed. This is the title page for presentations of the Erasmus project TOXOR, Learning Toxicology, through open educational resources. And now let us go back on the topic and include some more details. The first stage in addressing chemical pollution in different environmental media typically involves sampling and analysis to understand the nature of pollution, its extent, and potential effects. A detailed sampling and analysis plan is a crucial component of the first stage. The plan must specify the procedures by which samples are collected, the sample locations, and the appropriate sample number. It must also describe how samples are to be handled, transported, and analyzed. General questions. What types of chemicals are thought to be involved? What is currently known about the site in terms of contamination of environmental media and past waste practices? Is there a concern about past or future pesticide pollution? How do you expect human health or ecological systems may be affected by this problem? Is the work intended to comply with or achieve regulatory requirements? How will the data collected during sampling activities be used? To support risk assessment, to define the limits of contamination, to help develop a remedial action plan, or some combination of these? Questions about the site to be sampled. What have the past uses of the site been? Have past owners contributed to this problem? Is there a history of waste dumping at the site of nearby properties? Are there potentially multiple sources of contamination, both in terms of time and place? Based on what is known about prior activities, what types of compounds might be expected? Based on the time frames involved and breakdown products of chemicals of concern also likely to be present in appreciable amounts. Has the land been altered in ways which could influence pollutant movement or transformation? What sampling and analysis data have already been collected? Can these be used to rule out the presence of certain chemicals? Were prior sampling and analysis plans deficient in some regard that can be remedied? Here is a table of the environmental properties of some pesticides and their fate in the environment. Judgmental sampling. This technique is based on using personal judgment and opinion to select sample locations. Samples are placed where one thinks they ought to be based on what is known about the site and the particular interests in defining the contamination. The advantages of the judgment sampling are that it takes advantage of site-specific knowledge and experience and is fairly easy and straightforward to implement. On the negative side, this method is subjective and depends on one's knowledge being accurate and complete. Systematic sampling. Samples are allocated in consistent and predetermined pattern every 10 meters from a preselected starting point in all directions. The advantages of systematic sampling are that it is largely unbiased and objective, and the strategy is easy to explain. The negatives are that it either requires a substantial number of samples or supplies only limited coverage of the area in concern. Hotspots of potential contamination can be easily missed. Random sampling. In random sampling, one starts at a randomly chosen point in the sampling grid and then uses a random number generator to identify the locations to be sampled. The advantage, besides of being able to perform statistical operations on the collected data, is that it is recognized by regulators as being objective and unbiased. On the negative side, the random sampling is not applicable with extremely small sample numbers. One is just likely to miss a hotspot with small numbers of random samples. Stratified sampling. Stratified sampling combines several of the best features of the prior three approaches. Using site-specific knowledge, one can divide the site in question into different strata and then use different sampling strategies as appropriate. Stratified sampling has the advantage of reflecting site-specific information while still providing unbiased samples where appropriate. It does require site-specific knowledge and depends on that knowledge being correct. Otherwise, the strata selected might be inappropriate. Sample analysis. The final step to specify is how the samples are to be analyzed. The directions should include not only the analytical method, but also whether any sort of the pre-analysis digestion or treatment is required. Analysis methods should ideally reference specific protocols. When specifying the analytical procedures to be followed, one should consider whether breakdown products or contaminants should also be included. It is vital that the sampling and analysis procedure specify the necessary detection limits for all analysis to be conducted. Data reported by the laboratory as below the detection limit will be useless if the detection limit is higher than the relevant regularity of risk criterion. At the end of the presentation is the closing page of the Toxor project, where you can see the logos of the participating educational institutions from 7 European countries.